So conditional statements. This is a conditional statement. If it's raining outside, then we will play indoor football. So there's a condition to this. If this, then that. So if you come late to class, which none of you did today, which is great. If you come late to class, then you miss the beginning instructions. If you study for a test, then you should do well. If the sky is blue, then it's not raining. So these are different conditional statements we can make. I could make an outrageous one like, if it is sunny outside, then I'm going to have ice cream for lunch. It's a conditional statement, but it makes no sense. So just because something is a conditional statement doesn't mean it needs to make sense. It just means it has to have a condition. If this, then this. And so that's what we're getting into today. So for this first part, there's two parts to our conditional statement. There's an if part, and there's a then part. Did any of you watch the video yesterday? Okay, so then this will be a quick recap from yesterday. So the if part, this is what's called the hypothesis. So you probably have heard hypothesis before in terms of, say, science. This is like an initial guess. So this is what I'm proposing, if it's raining outside. So we're saying it's raining outside. What happens? Then we're going to play indoor football. So this is our conclusion. So hypothesis, conclusion. So if I hypothesize this happens, we can conclude that this happens. And for these, I call the hypothesis Q. This is just how I'm going to represent it. And I'm going to represent the conclusion as Q. I'm not sure why they picked those. They just picked those as the letters to represent it. That's a great question. I don't know why they picked P and Q. That's just what they did. So, and you need to know this because we are going to use that information in order to write some things out. So you need to remember which is P, which is Q. So in looking at this statement, yeah, I don't have it because you came late to class and I'm in the middle of teaching, so I'll have to get it once I'm done.
You're done like teaching over?
Yeah.
22 minutes.
This is the consequence of you coming late to class.
I want a partner?
Nope.
No.
So there's two possibilities for P. Either it's raining outside or it's not. This might seem really straightforward, but we need to go through this. If it's raining, P is true. If it's not raining, P is false. So if you look outside, today the P is true. It's not true. It's not raining. And there's two possibilities for Q. Either Q is true or false. So we are going to use that and try and figure out if this statement is overall true or overall false. So let's consider this statement, or two situations. So it's raining outside and we'll play indoor football. So let's suppose it's raining outside, and let's suppose we're playing indoor football. So both P and Q are false. Would this statement overall be true? And that's what we need to think about. So it says, if it's raining outside, then we play indoor football. So it's both raining and we're playing indoor. So this overall statement is true. Because I have the initial thing is true, the final thing is true. Let's look at another situation. So first of all, it's raining outside. So P is true. And we're not playing indoor football. So that would make Q false. What would my conditional statement be overall true or false? Well, let's think about this. My statement says, if it's raining outside, then we'll play indoor football. I just told you it's raining outside, and we're not playing indoor football. So this has to be false. Because you're told, if this, then we'll play inside. But we're not playing inside, so therefore this is false. Same thing, if I used another statement and said, if you study for a test, then you will get an A. How many of you have studied for a test and not gotten an A? And have not gotten an A? So you got a B or a C or you failed. I'm part of that group. I studied for a test and didn't get an A. So that would make that statement false. So in order to determine if these statements are correct, we're going to use something called a truth table. And with this truth table, we can determine if the overall statement is true or false. And so you see here I'm using P and Q, and this P with the arrow to the Q means P implies Q, or P, if P, then Q. It's just a mathematical formula to write this out. So we can write what we just did in a truth table. So we can say if P is true and Q is true, so if the hypothesis is true and the conclusion is true, the overall statement is true. If I do B, so my hypothesis is true, the conclusion is false, then my overall statement is false. I'm going to do this with some more examples so you can get more familiar with this. But we can also do the two other cases here. So the nice thing is if the initial statement is false, it doesn't matter what the other one is, my overall statement is true. So if my hypothesis is false, who cares what the other one is? My statement is true. So really the only case where you're going to have a false conditional statement is if the first part is true and the second part is false. Otherwise my statement is true. Because if I tell you, if we look back at this statement and I say, if it's raining outside, then we'll play indoor football. What if it's sunny outside? Well, it doesn't tell us anything about this statement. This statement only is applying to when it's raining. So if it's sunny, I could be indoor, I might be outdoor, it doesn't matter. You can see how this section could be some people's favorite or it could be some people's downfall, because this is a lot more thinking than it is actually equations. So let's look at a specific example here. I'm not going to do all 4 examples, I'm just going to look at a few of these. Okay. Do you guys know what a polygon is? It's a shape that is enclosed. So it doesn't matter how many sides are on it. As long as it closes off, it's a polygon. So if a polygon is a triangle, so if we have a triangle, then it has 3 sides. Would that be true? If a shape has 3 sides, sure, that's a triangle. If a polygon has 3 sides, then it's a triangle. That's also true. And so if you have a shape that has 3 sides, it must be a triangle. If a polygon is not a triangle, so if it's anything other than a triangle, then it does not have 3 sides. That one's also true. So if a polygon does not have 3 sides, so it has 1, 2, well you can't have 1 side. If it has 4, 5, 6, then it must not be a triangle. Also true. So in this one, we have all 4 of these cases are true. And these are actually different kinds of statements. So the first 2 we've actually looked at already. The first one is our basic conditional statement. This is what we started with. The second one is what's called the converse, and that I talked about this yesterday. So the converse meaning, notice I just switched triangle on 3 sides. So I started with a polygon's a triangle, 3 sides. Then I said if a polygon's 3 sides, it's a triangle. So all I did is just switch the hypothesis and the conclusion. How does the first statement compare to the third statement? What's the difference between those two?
One's waving, but not.
So this one says, is a triangle, is not. Has 3 sides, doesn't have 3 sides. So what I'm doing is called negation. I'm making the negative of those statements. So what statement 3, this one's called the inverse. So these are 4 terms that you'll need to remember. And the last one, I made it negative, and then I switched them. So there's normal, switched, normal, negative, switched normal, or switched negative. And this last one, I don't know where they get these words from. This one's contrapositive. Yep, exactly. Contrapositive. I'm sure there's a word study you can figure out where it comes from, but I'm not sure. So these are the 4 different types of conditional statements you could have. So I can give you the original original statement and say, what's the converse? What's the contrapositive? What's the inverse? And you'll need to write out what those are. So let's officially define these 2 new ones. So we've got an inverse, which means a statement formed by negating, so making the negative, both hypothesis and conclusion. Then here we've got contrapositive. Which is just either the converse of the inverse or the inverse of the converse. Anyone getting overwhelmed with all the new terms? Just a little bit. You can reread this if you want. This is just re-explaining this. Here it says converse. So let's do an example that hits closer to home. You're good? Okay, so we've got a geography teacher that makes this statement. If you live in Cairo, you live in Egypt. Would you say that's true or false? That's definitely true. If you live here in Cairo, of course you live in Egypt. So that's a true statement. Let's figure out what the converse is. Yeah, there you go. So if you live in Egypt, then you live in Cairo. So let's write that out. Actually, I'm going to type it because this is going to go quicker than writing it off.
We write this one, it's false.
So if you live in Egypt, then you live in Cairo. Well, let's think about this. So yesterday I talked about a counterexample. So what would be a counterexample to prove this false? What would be a situation where you live in Egypt, but it's not in Cairo? Alexandria, Fayoum. Yeah. So any other city than Cairo you could live, and you're still in Egypt and not in Cairo. So this, oops, I need to switch back to the pen. Does that make sense with the counterexample? So as long as you can, if you can come up with one counterexample, the whole statement is false. You just need one. All right, what would be the inverse? Yeah, so you just take this, make it negative. So if you don't live in Cairo, then you don't live in Egypt. Would that be true or false? False? Give me a counter. Yeah, so give me a counterexample. Same thing as the last one, right? So think about a place where you don't live in Cairo. So make this part true, but make this part false. So that's also a false statement. How about the last one here? Contrapositive. Yeah. So just take your inverse and switch. Or take your converse and make it negative. So it's kind of like the mix between these two. So if you don't live in Egypt, then you don't live in Cairo. Say that one's true? How come? Yeah. So think of a place where you don't live in Egypt. So make this initial part true, but make the final part false. Is there a way that you cannot live in Egypt, but you're in Cairo? That wouldn't make sense, right? You can't be outside of Egypt and live in Cairo. There's no part of Cairo that's outside of Egypt. So this statement is true. So this is a kind of question that I will give you on a test, or can give you on a test, where I give you an original statement. You need to make the converse, inverse, contrapositive, write out true and false. This would be a great question to give you. Any questions with that?
I have a question with
Yeah, we're gonna get there. So we can write out all these statements with proper notation like this. And what that looks like, let's go back and look at what this is. So remember, this part, the if part, this is P, and the then part, this is Q. So in my original statement, I'm saying this. P implies Q. P, if P, then Q. In the converse, I switched those. So I said, if Q, then P. What's that? This is the converse. So I just switched P and Q. If I do the inverse, it's the same as the original, except I'm making it negative. So negative is this weird sideways L thing. So it goes not P implies not Q. So the sideways L thing just means not. So it means if not P, then not Q. It's kind of like a minus sign with a little tail on it. You can think of it that way. So it's negative with the tail. And then what would the contrapositive look like? How would I write it? This one? Almost the same. You just switch the point. So it'll be, yeah, negative Q means negative P. So be careful with notation, because that is also going to show up. You need to recognize what that means. The nice thing is, the contrapositive always looks like this. That's not going to change. Same with the inverse. It always looks like this. So there's nothing new to give you with this. It looks exactly the same every time. So I know the notation isn't the nicest, however, it will not change. So that's the nice thing about it. Did that answer your question?
Yeah.
Okay, perfect. What have we got next? All right, is this? I think this will be the last one I do. And then the rest you can try it out and I can tell you if it's right or wrong. So here's our conditional statement. If today is February 29th, everyone knows what February 29th is, right? Normally February only has 28 days. Every 4 years there's a leap year. You have 29. You should know this. So if today is February 29th, so here's the P, then it's a leap year. Here's a Q. So we need to verify this statement. So either we say it's true and provide evidence, or we say it's false and come up with a counterexample. So let's try and think of this. Is there a way that I can make this true and this false? So let's say that today is February 29th. Is there any way that it is not a leap year? Can you have a February 29th that is not on a leap year? No. February 29th only occurs on a leap year. So to prove this, we make a truth table. So we go through this. Okay, if P is true, Q only has the option to be true, so therefore the overall statement is true. So this is how you'd quickly verify it. Just make a quick table to show that it's true. Let's talk about the inverse. So what would be the inverse of this? So trying to remember, is inverse the negation? Is it just switching them? Which one is the inverse? If you need help, you can flip to the page before. Yeah, so the inverse is just making these each negative. So I just take the original statement. If today is not February 29th, then it is not a leap year. So what do you think? Is this true or is it false? Is there any way that today is not February 29th, but it is a leap year? Yeah, this one's definitely false. But what's your counter example? So let's see. Let's pick a day that's not February 29th. January 1st? If it's January 1st, does that mean it's not a leap year? Does a leap year have January 1st in it? Does a leap year have every other day of the year in it? Yeah. So just because it's not February 29th does not mean it's a leap year. So January 1st in a leap year or during a leap year. Does that make sense? Hopefully it does. So let's try the contrapositive. So the contrapositive is switch them both, make them both negative. So to do that, we'd say if it is not a leap year, then it is not February 29th. How about this one? Is this true or false? False? Okay, what's your counterexample? Okay. Yeah, which would then mean it's not February 29th, right? So your argument is correct, it's just arguing that it's true instead of arguing it's false. So in order to do this, we need to think about this. Let's think about a leap year, or let's think about a year that is not a leap year. So three years out of 4. Is there any way you could be not in a leap year and have February 29th?
No.
No. Because February 29th only occurs in a leap year. So this one's true. And this is saying not Q, or if we made a truth table here, so not Q, not P, and not Q implies not P. So if this statement's true, it's not a leap year, this statement has to be true. There's no other option. So this overall table would be true. If you wanted to make a truth table for this one, so saying not P, not Q, just so you can see what it looks like when it's false, we would say this. So this is true. I just came up with an example where this is false. So therefore, the overall statement is false. So just so you see what it looks like when it actually is false, it's like that. Just so you can have those both in your mind. So the thing with this unit, and you'll find that this pops up multiple times, is it's going to take some knowledge that maybe you don't know. So there might be some stuff like maybe you hadn't thought about or didn't understand about February 29th and leap years. Or it might ask you about animals that are mammals. So if you don't know what a mammal is, you won't understand that. Or just some cultural stuff in North America from the textbook that you might not understand. So if there's something you just don't know, ask. Because it might be that it's just something that you don't know. Same thing on the test, I might have to help you with some of that stuff.